Hi, this is our DSC 478 final project, which focuses on Rent the Runway, which is a service of clothing rentals of luxury items. This is the README file, and it can be referenced if you have any questions while grading the assignment. We'll start right here with our initial exploratory data analysis. As you can see, there's over 190,000 observations and 15 features. And then we looked for nulls, and then we did histogram analysis on our numerical variables. One key takeaway here is that a majority of the age of our users is 25 to 40, so mainly in the young adult section. And then we also looked at our categorical variables through use of a bar plot, which you looked at fit, the bus size, and other categorical variables in our data set. One key takeaway here is that a lot of the body type is hourglass and athletic. And then we also did distribution analysis of multiple variables. As you can see here, we were able to identify outliers in this process. Then we also looked at the matrix sparsity, and what we found was pretty interesting, that the interaction of our matrix is fairly sparse at around 99.97%. The next notebook we'll go over is our collaborative filtering methods of item-based, user-based, and then we do alternating least squares matrix factorization to gauge performance. So here, we just read the data. And then we also reduced the size of the data set because we're having performance issues with the full size of it. So we focused on two categories of gown and jacket. And so this lowered our dimensions to around 46,015 columns. And we'll be mainly focusing on these three columns of item ID, user ID, and ratings. As you can see in the category here, we have a lot of gowns because we're focusing on gowns and jacket now. And so we're going to start with item-based collaborative filtering. And so first we just performed the method that we did in class, which isn't very efficient, as you can see here. And then this is our method going further. So we created the item matrix. And then we did a function to predict the user, recommend the items. And so as you can see here on the above cell here, the top 5 items similar to item ID recommend here. So it's item 1, item 2, 7, and 19. And then here's our user-based using k-means clustering. And as you can see here, we identified the amount of clusters by identifying the elbow at about 125 clusters. And so we fit the model, we predict it, and then we get our clusters going through the data set. And then we get our cluster centers, our centroids in terms of the item IDs. And then we're able to see the cluster sizes. And then we're able to measure the quality of the silhouette values. The silhouette just measures how similar an object is to the cluster compared to other clusters. And so a helpful visualization that we covered in class is we can see that a majority of it is above the mean cluster, or the silhouette score, which is good, but we just have this small amount here, which is below. And so we were able to perform cluster prediction on this by splitting it into a training and test set, and with our our item user matrix being our X and our clusters being our Y. And as we can see here, we get our similarities here and our clusters here, which are the last 2 columns in our data set. And then we finalize it with the labels right here. And then we can also gauge performance on this by looking at our accuracy. And as we can see here, we found our accuracy to be around 98%. And this was a method, next we found a method of alternating least squares. This was a method we found online, and we implemented it with our data set. And essentially what you're trying to do is compare the actual items bought in your recommendation simulation compared to the most popular items. And so we did this through first creating a train and test set, and then performing alternating least squares within the implicit package. Then we calculated the AOC scores, which is the area under the curve, and that calculates the probability of a random positive value and a random negative value. And so then we run like a random test, and then we get the mean value of what's actually bought, which is this here, 50, and then the most popular items. And then we tried to run the mean absolute error on this, but this took too long, just given the size of the data set. Next, we'll look at matrix factorization, and this is broken into two parts of distinct users and 2,500 users, and that's just because it would have taken 60 hours to run this on the full data set. So this is just looking at no repeat users. And so we get our user item matrix as before, and then we perform matrix factorization, which we covered in class. And so the accepts matrix R, which is the user item matrix for the ratings matrix, and then it creates a matrix P and Q, where then we use stochastic gradient descent, and then eventually we calculate the dot product, and P represents how much the user likes a certain latent factor, and then Q refers to how related an item is to that latent factor. P and Q are initialized using the dimensions of the ratings matrix n times n, and then the matrix factorization is applied and P and Q are saved. And as you can see here, we run this with our error in time, and then we get our predicted ratings through the dot product as explained above, and then we get our mean absolute error. And our mean absolute error is a little smaller than what we seen in past in like assignments and in lecture, and that's because it's not performed on the full data set. And then essentially in our next matrix factorization with 2,500 users, this is performed with the same exact methods, but just with some repeat users. And then as you can see here, our mean absolute error is slightly higher because we use a slightly more larger amount of data. Thank you for listening. That is our project.